All right, so today we're going to get into naming ionic compounds. Nomenclature, ionic nomenclature. Nomenclature is just kind of a fancy way to say that we're going to name the ionic compounds. If you remember from bonding, ionic compounds are those that exist between a metal or a cation and a nonmetal or an anion. Okay, and these two bond together. When they do bond, the cation just gets its full name. So cation will give it its full name, and that's usually the first, or almost always, it's the first element in the formula. So the cation gets its full name. The anion gets its name with the "ide" ending. So we change the ending to "ide." Okay. The naming is actually pretty simple because we don't really do a whole lot. We just give the cation the full name and the anion the "ide" ending. So here's a couple examples I'm going to go through. LiF. So Li is lithium, and then F is fluorine. And since we changed the ending to "ide," it would be fluoride. So lithium fluoride, that's it. So LiF we call lithium fluoride. BaCl2, barium, is Ba. And then Cl is chlorine. We change it to chloride. Okay. Notice there's a 2 here, but that does not come into play in the name. The reason for that is because we already know that barium's charge is going to be the same and chlorine's charge is going to be the same, so we don't need to distinguish that. Okay, so barium chloride. And then this last one, Ca is calcium, and then P is phosphorus, so we change that to phosphide. So calcium phosphide is that third one there. Okay. Now, what happens if you are given the name and we need to know the formula? Well, that's where we're going to have to figure out the charges of them, because the charges are going to tell us how many of each we need to use, how many ions of each one. So if, for instance, I have something like potassium oxide, and I wanted to know potassium oxide, I want to know the formula. So what I'm going to do is I'm going to look at my periodic table and notice that I have numbers up above the groups. Those are the charges or oxidation numbers for each group. So if it's in group 1, it's going to be +1, group 2 is +2, skip over to the group 13 is +3, 14 is ±4, -3, -2, -1. Okay, so you have from here over, those are your metals, and those are going to be your cations, and then over here your nonmetals, those are going to be your anions. Okay, so the other one that I forgot to label on here, let me do that real quick. Silver is +1. So whenever you have silver or see silver in the formula or the name, it's +1. And then zinc is +2, and cadmium is also +2. Okay, so you might want to make a note of that, that those are always the same. Okay, so what I'm going to do, if it's potassium oxide, I come over here, potassium's in group 1, so it's going to be +1. Oxygen is in group 16, so it's going to be -2. So I'm going to write down that K potassium is K plus 1. I know oxygen is minus 2. Okay. Then what I'm going to do from here is I'm going to try and balance out the charges. Okay, so when these compounds form, they form neutral compounds. So the positives and negatives balance each other out. Okay, so if I have a minus 2 and a plus 1, how am I going to get these two equal to 0? Well, I'm going to need another potassium plus 1, because that would then give me two pluses, and that would balance out my minus 2. So therefore my formula here should be, or will end up being, K2O. Okay? Because then those two are going to balance out my charge here to make it a neutral compound. The other way to do it is if I have K plus 1 and O minus 2, I do what we call swap and drop. So we swap the charges or the numbers over and then drop them to the bottom because they become subscripts. So this 2 from oxygen comes over to the K, and the 1 from the K comes over to the oxygen. You drop the charges, it becomes K2O. Okay? So let's try another one. Let's try strontium nitride. Strontium nitride. So I know that strontium is right here in group 2, so it's going to have a plus 2 charge. And I know that nitrogen is right here in group 15, so it's going to have a minus 3 charge. So strontium, write that down, plus 2, so Sr plus 2, nitrogen minus 3. So how am I going to get these to be neutral? Again, let's swap and drop. Okay, so we have Sr3, the 3 from nitrogen goes over there, and then the 2 from the strontium goes over to the nitrogen. So Sr3 and 2. Okay, and if we write that out, we have 3 Sr. So Sr, 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 plus 2, plus 2, plus 2, and then we have 2 nitrogens minus 3. So I have plus 2, plus 2, plus 2. Add those together gives me plus 6. And then 2 of the minus 3s gets me minus 6. If I add those together, that's going to give me a 0 charge, a neutral charge. Okay. Let's do one more. We'll do aluminum. Aluminum bromide. Aluminum bromide. Okay, so aluminum is right here. It's in the plus 3 column, group 13. So aluminum is plus 3. Bromine is negative 1. So bromide is negative 1. So I have aluminum. It's plus 3. Let's scoot that up a little bit. Aluminum is plus 3. Bromine is minus 1. Crisscross Al1 Br3. Again, the 3 from the aluminum goes over to the bromine, the 1 from the bromine goes over to the aluminum. And again, I could write it out. I need 3 negative 1s to cancel out my positive 3. Okay. So this is how you do ionic nomenclature for binary compounds. Let me know if you have any questions.